Hi, it's Carly McAvoy. I'm continuing to talk about quadratic equations. And in this video, I want to make a better graph than I did in the previous one. The last one was like make a rough sketch, but I want to find a lot of things out about this graph and draw it. So this graph is in what I would call standard form, and I want to find the orientation of the graph, which is, does the graph open up or down? And all I do for that is look at the a value. Now remember that this is ax squared plus bx plus c. So when I talk about a, I'm talking about the coefficient of the x squared term. And when I talk about b, I'm talking about the coefficient of the second or first degree term. The second term, which is the first degree term. I said that very confusing. The orientation of the graph, because this is positive, is up. So we know our graph is going to open up. The y-intercept is what you would get if you made x 0. In this format, it's very easy to see the x's would become 0, drop out, and I would get 12. The x-intercepts, if they exist. Now remember, x-intercepts have a y value that's 0. And we could have none, we could have 1, or at the most we could have 2. So we want to see if there are any. If there are any, they're going to have a y value of 0. So we take the f of x and we set that equal to 0. And then we factor. And so this is not a video about factoring, but I do have videos about factoring if you want to go back and watch them. The numbers I'm looking for multiply to be 12 and they add to be 8, and that happens to be positive 2 and positive 6. So when I set both of those equal to 0, I get x is negative 2 and x is negative 6. So I have two x-intercepts and they happen to be negative 2 and negative 6. Now, when I want to do the vertex, I want to use my negative b over 2a and then plug in x. That's how I find the vertex in this format. So negative b, well, our b is 8, so I'm going to get negative 8 over 2 times a, which is positive 1, and so I'm going to get negative 4 for the first half of my vertex. Now I'm going to go back and plug that in to find the second half. So y equals negative 4 squared plus 8 times negative 4 plus 12. And that would be 16 minus 32 plus 12. So is that right? Negative 16 plus 12 is negative 4. So we get negative 4 there. And of course you can do that in your calculator off to the side on paper or whatever. Just so we know what the domain and range is, we can see the domain and range. For a parabola, the domain is always all x values. There's nothing that's keeping us from that in a quadratic equation. So the domain is all x values. We can do it this way, negative infinity to positive infinity. We could just say all real numbers. We could say x is a member of the real number, something like that. The range, though, has to do with the vertex. Where's the lowest point? And then from that, in this case, it's the lowest point, because we know that it's opening up. So our graph has an orientation that looks like this. So down here, negative 4 is going to be our vertex. And that means that y can be negative 4 or higher, but it can't be anything more than that. So I'm going to do it in set builder notation, the set of all y, such that y is greater than or equal to negative 4. Another way you can see range written sometimes is in interval notation, negative 4 to infinity, with a square bracket there because that includes the negative 4. Depends on how you're asked to give your answer. The equation of the axis of symmetry also comes from the vertex. It's always this symmetry around that down the center, and that's the x value. So the equation is x equals negative 4. That's going to be it. And then we're going to graph that, and I have something here to help me graph that. And so if I go back and say what was my y-intercept was 12. What was my x-intercept? Well, they were -2 and -6. What was my vertex? Well, it was -4, -4. And so I have this information. I also know that my graph, I always know that a parabola has a line of symmetry that goes right down the center of it. So it's right there. That's the line of symmetry that I found when x was equal to -4. But what I want to do is make sure I don't make a V out of this, because I tend to do that. It's a U shape, and it would be looking like that. So that's a little more accurate, knowing exactly where it crosses the x-axis. Remember, it doesn't always have to cross the x-axis. We can have a parabola that doesn't ever cross the x-axis, or we could have a parabola that touches the x-axis one time. So we can have, for x-intercepts, we had 2 this time, but we could have none or 1 as well. All right, have a fantastic day. We'll see you next time.